Here are the notes for Chapter 2, Section 5. We're going to look at complex roots and numbers. First thing I'd like you to do is take a look at the graph of x squared plus 1. Okay, we can put it in our calculators. We should recognize this is the graph of our parent function x squared shifted up 1. Okay, and what I'd like you to notice is that this graph does not cross the x-axis. So there are no x-intercepts. So what's going to happen if we try to solve this, say we took our x squared plus 1 and set it equal to 0, we would have x squared equal to -1, and we know that if we square a number, it's going to be positive. Therefore, we say there's no real answer. Alright, but lucky for us, there is an answer. It is called the imaginary number. Alright, the imaginary number I is the square root of -1. And we have this square root of -1 is so we can simplify our negative square roots. Alright, so we know that I is equal to the square root of -1. Something else that's going to be important for us, I squared, if we square the square root of -1, we get -1. Okay, the square root goes away when you square something. If we're going to apply this to solve for our radicals, let's do a couple examples. Let's say we had the square root of -36. What we want to do is factor this into the square root of 36 and the square root of -1. And when we simplify this, we would get 6i. Okay, and this is how we're going to use this imaginary number in our problems. Okay, let's try a couple more. Let's look at the square root of -18. We're going to break this into the square root of 9. There's our perfect square. The square root of -1, and then we still have the square root of 2. The square root of 9 is 3. The square root of -1 is I, and the square root of 2 will stay in our answer. And this is the order that we'll typically see our answer. It usually goes number, I, and then a square root if there is one. Alright, let's do one more. Let's say the square root of -48. And our factors here, 16, -1, and 3. The square root of 16 is 4. The square root of -1 is I. The square root of 3 cannot be simplified. Alright, so a few examples of how we're going to use I to simplify our radicals. And here we have just 3 different ways to talk about imaginary numbers. Okay, so the words, it's the square root of negative, depending on what the number is. Usually whatever the number is comes first, like we wrote 3i or 6i. B is the real number, I is the imaginary number. The square of the imaginary number is the original negative number. Okay, so like we said, if we squared this, we would get the original negative number. So if we squared, say, the square root of -5, the answer would be -5. Okay, so just in numbers what that last part is saying, which we also have over here. Square root of -1 is I. Here's an example of how we factor our radical to simplify. Another example here with a perfect square. And then here, if we square a negative number, we get the original negative number. Okay, here's some algebra. If b is a positive real number, then the square root of -b is I times the square root of b. It's just like we saw on the last page, taking the I out writing the number first. Okay, so just 3 different ways of saying the same thing. All right, let's do some more examples of expressing numbers in terms of I. First, let's take the square root of negative 96. First thing that we want to do, make our lives easier, let's see if any perfect squares go into 96. All right, so let's think 4. Let's see, 4 goes into 96, but let's see if there's a higher one. 9 does not, but 16 does. Okay, 16 I think might be the highest one. So we have the square root of 16, we have the square root of negative 1, and the square root of 6. Breaking up this into factors. So now we have 4i root 6. Okay, let's try another one. 2 times the square root of negative 36. All right, the 2 is going to stay. Factors of 36, well, 36 is a perfect square, so we can do these two. Then we get 2 times 6i, which is 12i. There we go. And number 3, let's do the square root of negative 63. Let's think of the perfect squares that go into 63. 4, oh, how about 9? Yep, 9's going to work. So we have 9 times negative 1 times 7, which gives us 3i root 7. Okay, solve the equation. What we're going to do now, x squared equals negative 144. So like we said in the beginning, there's no real answer to this. Okay, but now that we have imaginary numbers, we can solve for x. Okay, so if we square root both sides, first thing, most important, don't forget when you're solving a quadratic equation like this, plus or minus goes before the square root. Alright, anytime you're solving an equation like this, you need that plus or minus. Okay, now from here, we're going to simplify it the way that we did the previous ones. So 144 is a perfect square, and then the I takes the square root of negative 1. Alright, let's try another one. X squared plus 48 equals 0. Now we might recognize this. We've solved some binomials before, okay, but 2 big things. First, 48 is not a perfect square. Second, it is addition here, not subtraction. So this does not fall into our perfect square factoring formulas. So what we're going to need to do for this, subtract 48 from both sides. And now solve, we're going to take the square root. We're definitely not going to forget that plus or minus. And now we just simplify the square root. And we simplified this on the other page. We're going to get the same answer, 4i root 3. Okay, let's try another one. Oh, I forgot to number that. This is number 3. 5x squared plus 90 equals 0. Okay, so notice again, no perfect squares here, and we're adding instead of subtracting. Okay, so not one of our formulas. What we're going to do is isolate the x squared. First by subtracting the 90, then we're going to divide by 5. Alright, and negative 90 over 5 is negative 18. Alright, just move up here. So x equals plus or minus the square root of negative 18, which we simplified earlier, plus or minus 3i root 2. Okay, and let's do one more. Let me see if I can fit it in here. Number 4. 9x squared plus 25 equals 0. Okay, now we do have some perfect squares here, which are always nice, but we're adding instead of subtracting, so it's not our difference of two squares formula. Alright, so we're going to subtract the 25, divide by 9, take the square root, let me move over here, x equals plus or minus the square root negative 25 over 9, which is plus or minus, the square root of negative 25 is 5i, the square root of 9 is 3, that is our final answer. Since we're dealing with negative numbers, we have a special term here called complex numbers. A complex number is a number that's in the form a plus bi. Okay, I is our square root of negative 1 that we've been talking about, and a and b are real numbers. Okay, every complex number has a real part a and an imaginary part b. Okay, so they all have to be in that form a plus bi. The real part is a, the imaginary part is the bi. Alright, two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Alright, so for example, if we have 2 plus 3i, this would be equal to 2 plus 3i. Okay, real parts are equal, imaginary parts are equal. Alright, so here's an example. Find the values of x and y that make each equation true. Okay, so we have negative 8 plus 6yi equals 5x minus I root 6. Okay, so think back to what we need. We need the real parts to be the same, and we need the imaginary parts to be the same. So what we're going to do is set up two equations. We're going to evaluate the real parts. We get x equals negative 8/5. Then we're going to evaluate the imaginary parts, solving for y, and those would be our two answers. Alright, next example here, we want to find the zeros of the function. Now the only difference here with the zeros of our function, we're going to see some imaginary numbers. So what I'd like you to do is put this equation into your y equals and take a look at the graph. Okay, pause if you need to. Alright, when we see our graph, it's over here, it should look like this. It's all the way up here. Alright, and does not cross the x-axis. That tells us that our zeros are going to be imaginary. Alright, so first we want to think, can we factor this? Okay, what are the factors of 13? Let's see, 13 is prime, so just 13 and 1. And those factors do not add up to 4, which means we can't factor this. Okay, so what we need to do is complete the square. We set our equation equal to 0. Move the 13 to the other side. We have to take half of 4 and square it. Add that to both sides. Okay, now the term on the left is a perfect square trinomial. So the term on the left is x plus 2 squared. And when we add on the right, we get negative 9. Okay, remember that when you complete the square, when we factor, this term is always half of b. Alright, let's finish this up. Square root both sides. Absolutely not forgetting that plus or minus. Simplify. Bring the negative 2 over. Plus or minus. Square root of 9 is 3. Square root of negative 1 is I. here are our two answers. So negative 2 plus 3i, negative 2 minus 2i. Minus 3i, sorry. So negative 2 plus 3i, negative 2 minus 3i. Okay, let's take a look at another example where we're finding the zeros. G of x is equal to x squared minus 8x plus 18. Alright, so first thing we're going to set this equal to 0. 18. Alright, and let's see, the factors of 18 are 3 and 6. Let's see, we can't get 3 and 6 to add up to negative 8 though. How about 2 and 9? Nope, they're not going to give us negative 8. 18 and 1. Not going to give us negative 8. Alright, so this isn't going to factor, so we want to complete the square. Alright, so we have x squared minus 8x. We're going to subtract that 18 to the other side. Next, we are going to take half of 8, which is 4, and square it, which is 16, and add that to both sides, giving us a perfect square on the left. X minus 4 squared equals negative 2. Square root both sides. Definitely not going to forget that plus or minus. Alright, so we have x minus 4 equals plus or minus. We can take the I out. 2 is going to stay underneath. And our last step, x equals 4 plus or minus I root 2. Alright, and if you want to check your answer to make sure that your answer makes sense, okay, not necessarily that it's 100% correct, but just to make sure it makes sense, you can take your equation g of x and graph it. If we look at the graph, it's going to look like this, noticing that it does not cross the x-axis, which tells us that our roots are imaginary, which makes our answer make sense. Okay, our last part here, we are talking about complex conjugates. If we have negative 5 plus I root 10 and negative 5 minus I root 10, these are what we call a complex conjugate. Okay, because the only difference in the two expressions, one is plus in the middle and one is minus. Okay, so a complex conjugate of any complex number, a plus bi, is a minus bi. Right? If a quadratic equation with real coefficients has non-real roots, okay, so all the examples that we've been looking at where we're getting I as an answer, those roots are complex conjugates. For example, the very last one that we did, our answer was 4 plus or minus I root 2. Okay, so those complex conjugates, 4 plus I root 2 and 4 minus I root 2. The only difference in the two expressions, one is plus in the middle, one is minus in the middle. Those are complex conjugates. A little helpful hint, when given one complex root, you can always find the other because it's a conjugate. Okay, so let's just write out conjugates for the first one. If we have 8 plus 5i, the conjugate would be 8 minus 5i. Only thing that changes is the sign in the middle. Okay, let's look at another one. What if we just had 6i? What we want to do is write this as a complex number. So 0 plus 6i. Now it's a little easier to see the conjugate, 0 minus 6i, and once we finish, we don't need to write the 0, and there's our answer. Okay, and you don't have to write the workout there if you don't want to, if you can see it easily, but I just wanted to show you how we get negative 6i. Alright, let's look at another one, 9 minus I. Nothing tricky about this one. The conjugate would be 9 plus I. Alright, our next one, let's say we had negative 4 plus 3i. Our conjugate would be negative 4 minus 3i. It's only the sign in the middle that changes. Okay, let's see. Our next one, I plus the square root of 3. So what we're going to need to do is write this in order and then change the sign in the middle. There's our conjugate. Alright, and our last one, negative 8i. So this is very similar to b. So for this one, it's really 0 minus 8i. So the conjugate would just be positive 8i.